Okay, over here I specified the integral on Desmos as the function of t from 0 to t, and this kind of proves that k is equal to 4, because in the problem, this is k, and we want the value to be 1, and as t goes, like at 100, the value is already 1, and at 1000, the value is 1. The question is, how do I come up with this value for k equals 4? To evaluate this definite integral, which has a limit at infinity, we rewrite it as the limit as t approaches infinity of the definite integral from 0 to t of kx e to the minus 2x dx. What we would like to do is evaluate this integral right here, and then take the limit of that as t approaches infinity. So I've kind of come down here, and this work down in here is just a matter of evaluating that definite integral. I've kind of ignored the k for the time being, and you do have to use integration by parts. So if we let u equal x and v equal the antiderivative of e to the minus 2x dx, du will be dx, v will be, you can use u substitution or substitution method here to get v as negative 1/2 e to the minus 2x. In other words, if you take the derivative of this, you get this. Okay, and then the integration by parts formula says that the antiderivative is uv, negative 1/2 x e to the minus 2x, minus the antiderivative of v dx. There's the v, and there's d, and d equal to dx. And if I change this to plus, move this 1/2 out front, make this a 1/2, and then take the antiderivative of e to the minus 2x, I'm going to end up with a minus 1/2 times 1/2. That's where this minus 1/4 comes from. Okay, so there's the antiderivative of this function right here. And I'm going to evaluate that from 0 to t, which means I'm going to put t in for x. And I'm going to rewrite e to the minus 2t as 1 over e to the 2t. Oh, that should have been a plus, a minus right here. Sorry. That's a minus sign. Oh, I can't erase it because it's not on the Wyzant board. Okay, so that should be a minus. Let me just, it's not going to matter, but I'll emphasize that's a minus. And then minus, put 0 in for x, and we get minus 0 minus 1/4. And if we simplify all that, we get a plus 1/4 at the end. That's where this plus 1/4 comes from. So now we're taking the limit of this thing. I move the k out front. As t approaches infinity of this entire expression right here, what happens? Well, if we focus on this term right here, you actually have to use L'Hopital's rule. What's the limit of t over e to the 2t as t approaches infinity? And that is L'Hopital's rule. This is infinity over infinity. That's enables us to use L'Hopital's rule. The derivative will be of the numerator will be 1. The derivative of the denominator will be 2 e to the t, e to the 2t. The limit of that as t approaches infinity is 0. So we get, for this term as t approaches infinity, we get a 0 plus the limit of this term as t approaches infinity is also 0. We have a plus 1/4 And we're multiplying that by k. So we get 1/4 k. And we want to know for what value of k does that equal 1. And that will happen when k equals 4. Okay, so there's a lot to that problem. Integration by parts using L'Hopital's rule. There you go. Hope that helped. And if you have any questions, post a comment.